From the pyramids of Egypt, the Parthenon of ancient Greece, the Eiffel Tower in Paris, or the Guggenheim in Bilbao, Spain. The process of constructing a building has always begun with an idea, communicated to a builder through a drawing. In ancient Rome, an architect would chisel life-size templates of columns and entablatures into the stone floors of a mason's quarry. In the 13th century, scalar drawing emerged. This is the idea that a much smaller unit will equal the actual measurement of what is being drawn. For instance, 1/8 of an inch will equal 1 foot. The first great cathedrals of the Middle Ages were drawn on clay tablets created by a master builder. They used the triadic system to design these great works of faith. The triadic system utilizes plans, sections, and elevations to describe a building from specific viewpoints. A plan is essentially what you would see if you cut through the building 3 feet above the floor and looked directly downward. An elevation is a view of each side of the building. A section is what you would see if you cut through the building vertically and looked through the open side. The triadic system is how architects have communicated the three-dimensionality of a building to clients and builders for the last 800 years. The clay and stone tablets gave way to linen and ink. Linen and ink gave way to vellum. Ammonia-based reproduction processes became available. Vellum would fall to paper as Xerox became commonplace. Regardless of the medium, how the architects designed changed very little over time. Drafting squares, parallel bars, triangles, compasses, and scales all aided the draftsman to make precise drawings with ink or pencil. In the 1980s, computer-aided drafting, known as CAD, began to gain in popularity and would displace hand drafting as the norm in the 1990s. Although the computer significantly increased the precision with which the architect could draw, the method to communicate the ideas to owners and builders did not change at all. The architect still relied on drawing lines to represent the three-dimensional object. And this has always been the greatest flaw in how an idea is communicated, because 10 different people could interpret the architect's intention 10 different ways, so valuable information is lost. This graph represents the amount of information that is gained about a project over time. As the architect makes decisions about the project, his understanding of it grows. When he passes the information to the builder, some information is inherently lost due to the builder's need to interpret the drawings. As the building is constructed, the builder learns more about the building until the day he hands the keys to the owner. The owner will never know precisely where all of the infrastructure is located, as the builder did, or why a room is laid out in a particular way, as the architect did. All this information is lost over time. The next innovation, though, is a disruptive technology. That innovation is known as BIM, Building Information Modeling. BIM is virtual construction of all the building systems using three-dimensional components. The structural system is modeled, the mechanical system is modeled, the walls and roofs and floors are modeled. Any item that is required to construct the building in the real world is included in the model. With a building constructed within the computer, it is possible for owners to walk through their planned buildings and understand how the spaces interact with one another, or not, long before changes can become costly. is much easier to move a wall made of pixels than one made of concrete block. Although 3D technology had been incorporated into CAD at the turn of the century, what makes BIM different? The I in BIM, information. Each component is embedded with parametric intelligence, so that the window knows it's a window. It knows what it's made of, how tall it is, how wide it is. All of this information can be extracted from the model and used by designers, owners, and contractors to better understand how the building will be put together, long before a shovel ever enters the dirt on a job site. The parametric intelligence within each component also makes the coordination of systems more precise. Because a steel beam knows it's made of steel, the model knows that no other items can pass through it. Conflicts between elements are more readily identified by the designers and altered long before resources are committed to construct the building. A model can be utilized to ensure that the building's energy usage will be known before it is ever built. Design solutions can be tweaked to their best possible orientation to ensure that the building shell is ideal for its climate and precise location. Daylighting can be harnessed to make the building even more efficient. And owners can understand how their buildings will react to all of the seasons. The intelligence of a model is also transferable as the project progresses. Using the triadic system, the owner and contractor looked at the drawings and interpreted the architect's intent. What might have been clear to the person who planned the building might not be as clear to another. With BIM as the tool to communicate the idea, there is no interpretation needed. The owner and contractors can see all the planned spaces and how the systems are coordinated with one another. This makes the building process much more efficient. Not only is the information beneficial through construction, it also becomes a virtual history of the building. Imagine how useful it would be to know exactly which pipe serves the restroom upstairs and which one is a conduit to the main electrical panel, without having to raise ceiling panels and trace it back to its origin. As facility management software catches up with design, it will be possible for building control systems, security systems, and other technologies to all be integrated and allow buildings to be tuned to the precision of a race car, saving clients valuable dollars that are wasted on mechanical systems that have fallen off their peak performance levels. BIM requires owners, architects, engineers, and builders to approach design in a whole new way, a way that is more integrated and comprehensive. This new collaboration yields buildings that are both efficient and beautiful. Although we'll no longer be able to say, back to the old drawing board, we're confident no one's going to miss it.